Hey guys, and I'm going to go over your study guide. By the end of this video, you're going to be able to review proportional relationships in tables, graphs, and equations and focus on areas of improvement. I want you to make sure that you are focused on the things that you're not so great at, not just doing the things that you're awesome at. So for this to work, you need to do the study guide first, then check it with the answer key on anything that you missed or you didn't understand. I want you to go to this video, press play, and skip around to all the parts or the questions that you needed to work on. You don't have to watch the whole video from beginning to end, just the parts that you have confusion or questions about. So I'll go ahead and get started with number one. In this section, it says solve each of the problems below. They represent types of questions on your test. Be sure to ask questions if you need more help with the topic. This first section, you should be able to determine if a relationship is proportional. So determine if the representations below are proportional or non-proportional. Here's how you tell from a table. For every y divided by x value, you should get a constant rate or the same ratio. So now look here, I do 5 divided by 2 and I got 2.5. I did 9 divided by 4 and I got 2.25. So immediately I can tell that this is not proportional. It says here I can just put NP, not proportional. You have to make sure you check for every value in the table, but if even the first two, the y divided by x doesn't match, the whole table is not proportional. We do the same thing with the next table. Every y divided by x should equal the same constant rate. It has to be true for every y divided by x in the table. That's what proportional means. So 0.5 is 1.5 divided by 3, and so on for each one of these. I check all of them just to make sure the whole table is proportional, and you can use a calculator to check these because this is kind of hard to do in your head. So in your calculator, you would just type in every y divided by their x, and if it's the same ratio for each one, which it is, it's 0.5 or 1/2, you know that this is a proportional table. We'll look at C and D together because these are two examples of equations. If it has a plus 0, or it goes through the origin, if it doesn't have something it starts with, it's proportional. This is an example of a proportional relationship because it matches the equation y equals kx. There's nothing else starting or adding to it. This one, however, has a plus 1/2. That means that it starts at a half, then goes up at a constant rate of 9. This is not proportional, even though it's increasing at a constant rate, because it has a starting point at 1/2. This one starts at 0, so it goes through the origin. And then the same thing is true for this graph. Even though it's decreasing at a constant rate, it does not go through the origin. So for it to be proportional in a graph, it has to be a straight line that passes through 0, 0. This one does not, so it is not proportional. In the next section, you should be able to find the constant of proportionality. Remember, constant of proportionality is just a fancy word to say the rate or the unit rate. Next year, we'll call it the slope. So determine the constant of proportionality in each of the problems below. So in the first one, you're given an equation. When you're given an equation, this should be easy. On your reference sheet, you can see that the equation for a proportional relationship is y equals kx, and k is always the number that's next to x. So the constant of proportionality, or the rate, is always the number that's multiplied by x. It's the one that's right next to it. So all you have to do is look at the equation and see what number is right next to x. That would be 1.5. So that would be your constant of proportionality. Let's look at it in the table. You're giving x and y values. We're going to assume that the table is proportional. So all you have to do in the table is divide any y divided by the x. So 190 divided by 2. That would be 95. You might also see this written as k equals 95 because we use the variable k to refer to the constant of proportionality. For C, it says a restaurant has an all-you-can-eat buffet. They charge $13.95 per person. Remember, the constant of proportionality is just the unit rate. This is $13.95 per one person. So the constant of proportionality is also $13.95. And then let's look at it in the graph. So in this graph, we know the constant of proportionality is per every one thing. So the first thing I want to check is I want to look at the x-axis and find the 1. I want to look up, and it's not an exact point. So what I want to do is mark out all of the exact points on here. So this is an exact point. This is an exact point. What I can do is I can take the coordinate. This is 2, 150. Remember, it's x, y. Walk before you fly. X comes before y in the alphabet. And when I want to find the rate or the constant of proportionality, I can always take the y divided by the x value for any point. So y divided by x here is 75. I can try it again here just to make sure. This is 4, 300. This is the same thing. 300 divided by 4 also gives me 75. So for the graph here, it's increasing at a rate of 75 miles per hour. Let's look at number 3. It says I can use tables to represent proportional relationships. We're going to complete this table below and use the information to answer A through C. So we'll start by completing the table. We'll assume that the table is proportional and increasing at a constant rate. We can look at any point on this table that is already filled out and take the y divided by the x to find that unit rate. So for example, I can find 10.5 divided by 3 is 3.5. Same here, 17.5 divided by 5 should also be 3.5, and it is. So I know that in this table for these x and y values, I'm going to go ahead and skip to b here. The equation for this table is going to be y equals 3.5x. That means that it's 3.5 for every hour. So when I know the number of hours, I'm going to multiply it by 3.5. So at 0, after 0 hours, 0 times 3.5 is 0. You also know that this is a proportional relationship, so you have to go through the origin. It has to start at 0, 0. You know that this is the unit rate, 3.5. So for every 1 hour, you have 3.5 inches of total rainfall. You can do 3.5 times 2 to fill out this missing point in the table. 3.5 times 2 is 7. You already have the 3 is 10.5. And then for 4, you do 3.5 times the 4. Remember the x value 4 just gets plugged into the equation. 3.5 times 4 is 14. This is your completed table. So part A says, after how many hours will the amount of rainfall be 28 inches? So the question is asking, after how many hours, x, will it be a total of 28 inches? So you're looking for the missing x in this situation. What times 3.5 will give you 28? You can solve this equation by dividing. If you divide 28, the total, divided by the rate, 3.5, you'll figure out what your missing number of hours is. So if you're looking at this from an algebra perspective, you can write x equals 8. You could also write, in context, 8 hours. Both these answers are correct. Either way, it's 8. We already did part B, and let's look at part C. If it continues to rain at this rate, how many inches of rain will fall after 6 hours? So I just rewrote my equation. I know x is the number of hours, and since I'm looking at 6 hours, I can put in a 6 for the x. So 3.5 times 6 will give me my total, and that would be 21 inches. You can write this as 21 inches or y equals 21 or y equals 21 inches. So let's continue this next section with writing equations to represent these proportional relationships. Question 4 says that an app developer projects that he will earn $20 for every 8 apps downloaded. Write an equation to represent the proportional relationship between the number of apps and the total earnings. Let's start out with just knowing what an equation for a proportional relationship looks like. It's always y equals kx. K is our unit rate, x is our input or our independent variable, and our y is our dependent variable or our output. We put something in to get something out. So let's identify what each of these variables are in this example. We'll start by finding the unit rate. Since it says there's $20 for every 8 apps downloaded, I can write that as a ratio. $20 for every 8 apps. The order matters. It's 20 divided by 8 because it's dollars per app. So 20 divided by 8 gives us our unit rate, which is 2.5. So simplify, that's 2.5 or 2.5. So now you know the K in the equation, or the unit rate in the equation. We also want to know what our X is. So what are we putting in and what are we getting out? We're putting in the number of apps. So the number of apps is our X. You also know that in this K equals, it's a Y divided by X, and it's written 20 divided by 8 apps. So apps is our X. It's always important to label what each variable means in the equation. It'll help you understand what you're solving for. And then let's solve for our last one. What does Y equal in this equation? Y equals the amount of money. Y is the amount of money he makes. So Y is the money he earns. Y is always going to be our total. So it's always going to be written Y equals K, which is 2.5. We can fill that in because we know that, and it's not changing. And X is the number of apps. That is going to change. So the number of apps is going to change. He could do 8 apps, 16 apps, and so on. He can go on and on and on. And then his money he earns is going to depend on the number of apps. So this would be the equation to represent this relationship. If you're having trouble on these, it's always going to be Y equals the unit rate times the variable X. So Y equals X, and then the number next to X is going to be the unit rate. Let's look at number 5. It says it takes Esther 12 minutes to ride a roller coaster 4 times. Write an equation to represent the proportional relationship between the number of rides and the total amount of time. We're always going to write our equations in the form Y equals KX, where Y is our total, and it tells us in the problem that's our total amount of time. And then X is our input, or the thing we put in. We put in a total number of rides to get out a total amount of time. So let's start by finding our constant of proportionality K, or our rate. It takes 12 minutes to ride the coaster 4 times. It's 12 minutes per every 4 times. You can write that as a fraction or a ratio. 12 divided by 4, which is 3 minutes per 1 time. So 3 is our unit rate. Usually minutes or time is our x-axis, but on this case, we're putting in a number of rides to get our number of time. So on this one, y is actually going to be the total amount of time. Since it says total, that's our hint. So y is usually going to be our total. This one, it's the total amount of time, which means that x is the number of rides. So we write our equation, y equals, it's always going to be y equals the unit rate of 3 times the x. Let's look at our last two on this page. It says use the table to write an equation to represent the constant of proportionality. So you're given a table. X is going to be the number of textbooks, and Y is going to be the total sales. So Y is our total. Y, our total sales, equals the unit rate, or the constant of proportionality, times our X, or the number of textbooks. So what is the dollar amount per one textbook is what we're looking at here. So we need to find the unit rate. You can do that by taking any point in the table and dividing the Y value divided by the X value. When I take 64 divided by 4, I got 16. So 16 is my unit rate. So the rule for the amount of money you make from the number of textbooks is y equals 16x. That's why this is the equation for my table. It'll always be in the form y equals the unit rate times x. So y equals 16x is the rule for this proportional relationship. And then last one, let's look at number 7. Let's identify what our x-axis is and our y-axis. So our x-axis is the horizontal and the y is the vertical. Our y, dollars, equals the unit rate per dollar per hour times the number of hours, x. So we need to find out our unit rate is. We want to look at the graph at 1 on the x-axis and just go up and see if there's an amount here. There is. It's $10 for every 1. If you look on the graph, it's increasing at a rate of $10 for every 1. You could also take any y point, like this one, and divide it by the x point. So 40 divided by 4 is 10. So it's constant along the table or the graph here that it's $10 per hour. So y equals 10x would be the equation that matches this graph. You can always type it into the calculator on the y equals button, y equals 10x, and it will show you this graph. All right, guys, that's it. If you made it to the end of this video, please put in the comments whether you're best at graphs, tables, or equations. Today, we just covered part 1 of the study guide, so we reviewed proportional relationships in tables, graphs, and equations. I want you to focus on your areas of improvement. So if you needed help with anything you saw today, please let me know. So go ahead and go back and finish part 2 of the study guide, and then you can check out the part 2 video. Let me know again if you have any questions. Bye.